All right, my kiddos, so today we are doing lesson 2.04, and it's called ions. Now I know on Tuesday we learned about isotopes, so you might want to review that video from lesson 2.03 from Tuesday, and if you need the link, just email me. I can send it to you. So there are two I words in chemistry that kiddos typically tend to mix up when they're first learning. And so from last week we did a couple days ago we did isotopes, which just is atoms, or just are atoms of the same element. Sloppy writing, Mrs. Kitson. Atoms of the same element with a different number of neutrons in the nucleus. And remember, we had isotopes like carbon 12 and carbon 13, and we had carbon 14. Right, they all have 6 protons in the nucleus. That's what makes them carbon. But carbon 12 would have 6 neutrons, carbon 13 would have 7 neutrons, and carbon 14 would have 8 neutrons. If you add those up, 6 and 6 is 12. That's where the mass number comes from. Okay, so 12 would be the mass number, 13, 14 for these different isotopes of carbon. Well, by definition, and we talked a little bit about this in the last video, atoms are electrically neutral, meaning they have no charge. So if you're carbon and you have 6 protons in the nucleus, I'll draw a little circle for the nucleus, you're also going to have 1, 2, 3, 4, 5, 6 electrons flying around on the outside of the atom. But atoms typically don't hang out in the form of atoms unless you're a noble gas, and we'll get into that a little bit later on in the year. But atoms typically don't keep their electron numbers stable. So what atoms typically do is they tend to form ions. And so once an atom, right, a neutral atom, has lost an atom that has, let's put that has lost or gained one or more electrons. So that's what an ion is. So now we're not, when we were dealing with isotopes, we were talking about a difference in neutrons. But now we're going to talk about a difference in electrons when we use the word ion. So here's what happens in a nutshell. Metals tend to lose electrons, and nonmetals tend to gain electrons. Now, electrons are negatively charged, right? So if you lose electrons, that means overall your charge is going to become more positive. If you gain electrons, that means overall, because electrons are negatively charged, so you're going to be gaining something that's negative, your overall charge is going to become more negative. And I'll show you what that looks like right here. So if you are, let's say, I don't know, let's be sodium. I lost my pencil here, or my pencil. So that's sodium, right? Its atomic number is 11, which means it has 11 protons, and we're not worried about mass number right now, so we're not going to worry about the number of neutrons in the nucleus. It's atomic number 11, so if I were to draw sodium, it would have 11 protons inside the nucleus. I'll draw a circle for the nucleus. That means it's going to have, as an atom, 11 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it has 1. There's that 11th electron way out there on the outside. So sodium, if you look at it on the periodic table, is in group 1. It's in the first column. And so all the elements in group 1, they all are going to end up having this one random valence electron. Valence electrons are the outermost electrons that an atom has. Okay, valence electrons. Those are the outermost, whoops, that's an O, outermost electrons. So sodium only has one electron on the outside in that outer ring. So sodium is going to readily, because sodium's a metal, sodium is going to readily lose that electron. Okay, it doesn't need it. So here's what happens. Sodium typically has 11 protons and 11 electrons as an atom. Once it becomes an ion, though, it's still going to have its 11 protons, right? But it's going to lose this electron out here. Okay, this electron is going to actually get taken away by another atom. And so instead of having 11 electrons, now it's only going to have 10 electrons. So if I add these up, I have 11 positives and 11 negatives. The overall charge would be neutral, or 0. But over here, when the sodium atom becomes an ion, now it has 11 protons and only 10 electrons. It's got one extra positive charge. So now it has a charge of +1. Okay, so as an atom, it's neutral. Same number of protons and electrons. But as an ion, now it has an electrical charge. What's really fun is when you write that as a symbol. So here's sodium. Sodium has 11 protons, so we usually put the atomic number down to the left. And when it's charged, it has a charge of +1. Okay, so when you're dealing with a neutral atom, you just write the Na. When you're dealing with an ion, so once that atom becomes an ion, in other words, it's gained or lost electrons, now you have to put that charge in the upper right corner of the symbol. That's how you know you're dealing with an ion. So we'll do a couple more. Let's do magnesium. Magnesium is atomic number 12, so I'll put that down there. So if I were to draw magnesium, it would have 12 protons in the nucleus. We're not worried about neutrons right now. 12 protons in the nucleus. If it's got 12 protons as an atom, it's going to have 12 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it's going to have 2 on the outside, 11, 12. Okay, we're going to practice drawing these next week. So you can see it's got 1, 2 valence electrons out here. So magnesium, being in group 2, the second group over, is going to readily lose 2 protons. Another atom will come and take them. So normally, right, magnesium has 12 protons and 12 electrons as an atom, a neutral atom. If I add 12 positives and 12 negatives, I get neutral, 0. But as an ion, it's still going to have those 12 protons. That's what makes it magnesium. But it's going to lose these 2 electrons. So instead of having 12 electrons, now it's only going to have 10, right? And so it's got 2 extra positive things, right? 2 extra protons. So now the overall charge is 2+. Okay, so as an atom, it's neutral. As an ion, anything in group 2, the second column on the periodic table, will lose 2 electrons. So if you were to write the symbol for this, oops, that's an M, you would write magnesium. It has an atomic number of 12, and when it becomes an ion, it has a +2 charge. Let's do one that gains electrons, and then we'll call it a day here for a little bit. Let me move this up. Okay, so on the other side of the periodic table, to the right, you have the nonmetals. And nonmetals, like I said earlier, nonmetals tend to gain, or they actually take electrons from metals. Okay, so the metals are losing them and the nonmetals are taking them. So a good example would be fluorine. atomic number 9, so it has 9 protons. Okay, so if I were to draw it as an atom, it would have 9 protons in the nucleus, and then flying around on the outside, it would have 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. And what you can see, interestingly enough, on the outermost valence electron shell, there are 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, now the magic number is 8. Elements like to have 8 valence electrons. Fluorine has 7. It's not going to get rid of 7 electrons. It's really easier for fluorine to go find one more, right, and fill in, whoops, where'd my pen go? And fill in this spot. Okay, so what fluorine does is it actually takes 1 electron from other atoms. So let's see what that looks like. So fluorine as an atom is going to have 9 protons and 9 electrons. 7 of them are on the outside, okay? And then as an ion, it's still going to have 9 protons because it's fluorine, and that's what makes it fluorine, but it gains 1 electron typically. So any element in group 17 is typically going to gain 1 electron or take an electron from someone else. So now once it becomes an ion, instead of having 9 electrons, it's going to have 10 electrons. So if I add those up, as an atom, 9 protons and 9 electrons is neutral. But as an ion, now we have 1 extra negative thing, right? We've gained an electron. So now as an ion, the atom becomes more negative. So it has a 1 negative charge. You can also write that as a -1 charge. So when you write the symbol, instead of just an F, now you have to put a -1 up there because you're showing everyone that it has gained 1 electron.